Hello, good morning. We are from Team Yoyo, with members consists of Cedrick, me, Clement, James, and Juan. And today we are going to do our presentation. Okay, yo-yo. A yo-yo is a toy consisting of a pair of joint discs with a deep groove between them, in which string is attached and wound, which can be spun alternately downward and upward by its weight and momentum as the string unwinds and rewinds. How to play the yo-yo. Slip the string on your yo-yo's Slip the ring on your yo-yo string onto your middle finger. Thrust your arm down, releasing the yo-yo and spreading your fingers. Give it a sharp tug when the yo-yo is fully extended to bring it back. To wind up the yo-yo, hold your yo-yo in your non-dominant hand with your pointer finger across your yo-yo. Wind the string around the yo-yo and your finger once. Then, loop the string 2 or 3 times underneath your finger, creating a loop. Remove your finger and wind up as normal. Repeat all the steps mentioned before.
Wait, alright. Physics concepts in yo-yo. There are potential energy, translation kinetic energy, moments of inertia, and law of Newton too. Potential energy. PE equals m times g times h, where m equals mass of yo-yo, g equals gravitation, and h equals height. In the first condition, when yo-yo is held on the hand, yo-yo is in a specific height. When the yo-yo is let go, it will fall. Therefore, it will reach the maximum limit of the rope. The change of height from the yo-yo is one of the principles of physics when playing a yo-yo. Translation kinetic energy. Rotational kinetic energy is the energy an object has because of its rotation. Kinetic energy. This is the kinetic energy formula. Translation kinetic energy equals half times mass times velocity squared. Rotational kinetic energy equals half times moments of inertia times angular velocity squared. For the kinetic energy formula equals half times mass times velocity squared plus half times moments of inertia times angular velocity squared. Translation kinetic energy is related to potential energy. When a yo-yo is let go from your hand, it will have a change from potential energy into a kinetic energy in a form of rotational and translational movement. That's why it's called translation kinetic energy. The value of kinetic energy in a yo-yo will always increase until the rope reaches its maximum length.
So the next one is the relation of kinetic energy and potential energy in yo-yo. There are three stages. The first stage is potential energy is as its maximum and the kinetic energy equals to 0. The second stage is potential energy equals to kinetic energy, and the third stage is potential energy equals to 0 and the kinetic energy is as its maximum. And the good moment of yo-yo sleeper is when the yo-yo is in the maximum height of the rope and it keeps rotating. Sleeper is the main factor when playing yo-yo because a yo-yo attraction can be done during the sleeper moment. Okay. And the next one is the moment of inertia. The way for a yo-yo to experience sleeper pace is to intensify the moment of inertia. Moment of inertia is the endurance of an object to change its rotation. Moment of inertia can be upscaled by adding mass and the mass length to the rotation axis. The moment of inertia that happens in a moment that happens on the hollow cylinder, and the formula from moment of inertia is I equals to k times m times r square, where I equals to moment of inertia, m equals to mass of yo-yo, r equals to yo-yo's radius, and the k equals to constant of yo-yo.
And now we have the law of Newton 2. So the law of Newton 2 is when yo-yo is let go, or we can say going down, it will have a change in acceleration. The formula, there are two. Number one, sigma f equals sigma m times a. The second one, to find the acceleration, you can use the formula m times g divided by m plus k times m. So F is force, A is the acceleration, M is the mass of yo-yo, K is the constant of yo-yo, and G is the gravitation. The next one is the angular acceleration. Angular acceleration happens on every phases when playing yo-yo. When it falls down, the sleeper phase, to when the yo-yo returns back up to the hand. The formula is acceleration equals alpha times the yo-yo's radius. The last one is the angular speed. The angular speed is the total from the beginning of the yo-yo when let go, and the angular acceleration multiplied with the time when the yo-yo is thrown until its rotation. So angular speed equals the beginning of the angular speed, and then we add it with the angular acceleration, or the alpha, multiplied by time. Here are some tips to play yo-yo better. Number one, adding the moment of inertia to the yo-yo by putting an additional mass at the edge of the outside disc. Number two, reduce the friction between the yo-yo and the rope so the sleeper phase happens longer than the usual. And the last one, if bigger force power is given to the yo-yo when dropping the yo-yo, the rotation itself, the speed of it, will be higher or faster, and the sleeper phase will be longer. So those are all of the materials for our presentation today. So thank you so much for your attention.